So now that we've gone over what big data is, introduction to data ethics, and you've had a little bit of an experience using a tweet sentiment analysis, let's actually talk about the mechanics of data science. And eventually we'll get to what's known as the data science life cycle, and we'll talk about a practical example of how that's actually used. So, what is data science? So, data science is the practice of mining large data, um, raw data, both structured and unstructured, to identify patterns and extract actionable insight from them, such as the sentiment analysis, tweet sentiment analysis. So, it's an interdisciplinary field, and the foundations of data science include statistics, inference, computer science, predictive analytics, machine learning, algorithm development, and new technologies to gain insights from big data. So, what's the difference between data science, artificial intelligence, and machine learning? Artificial intelligence, also known as AI, means getting a computer to mimic human behavior in some way. Data science is actually a subset of AI because it refers more to the overlapping areas of statistics, scientific methods, and data analysis, all of which are used to extract meaning and insights from data. Machine learning is also another subset of AI because that consists of the techniques that enable computers to figure things out from the data and deliver AI applications. So, how is data science actually transforming business? Well, organizations are using data science to turn data into a competitive advantage by refining products and services. Data science and machine learning use cases include determining customer churn by analyzing data collected from call centers so that marketing can take action to retain them. So let's say you wanted to change your cable service or change your phone service. Whenever you call, they'll keep track of how many people actually terminated the service, how many didn't, based on being given some additional offers. But that's all related to customer churn. Improving efficiency by analyzing traffic patterns, weather conditions, and other factors so that actually logistic companies can improve delivery speeds and reduce costs. This is key in the transportation industry. It's key with airlines. It's key with the trucking industry, where they need to make sure that they are the most efficient as to how they're using their products. Improving patient diagnosis by analyzing medical test data and reported symptoms so doctors can diagnose diseases earlier and treat them more effectively. Optimizing the supply chain by predicting when equipment will break down. We have recently had some issues with supply chain, issues with gasoline, and data science can be used to try and potentially predict how long the supply chain would be interrupted and where it would be interrupted. Detecting fraud in financial services by recognizing suspicious behaviors and anomalous actions. This is actually more prevalent right after 9/11, where there were additional regulations and systems put in place to track financial transactions between the United States and some Middle East countries. And improving sales by creating recommendations for customers based upon previous purchases. You'll see this, I'm sure, using Amazon. You'll see it also in the media using Netflix and Spotify. So let's talk about the data science lifecycle. So if you're working on a project as a data scientist, you'll actually probably be following each of these 7 steps in the data science lifecycle. It's important that you understand what each of them means and how they fit together to actually be able to develop an effective analysis of the data that we're bringing in. So let's take a look at the first one. So business understanding. So the first thing you need to do in any project is ask relevant questions and define the objectives for the problem that needs to be tackled. So for example, I used to do some analytical work on predictive modeling of student retention at ASU. So some of the questions that I needed to ask are, so what are the characteristics of the students that I wanted to analyze? Second thing, once you get that basic understanding of the business and for the project, you will go to your next step, which is data mining. So that's actually gathering and scraping the data necessary for the project. So how much data do you want? What years would I be including? How many years would I want to go back? The third step, which is also key, is data cleaning. So you're going to fix the inconsistencies within the data and handle the missing data. So sometimes what you're going to have with missing data is you're going to need to impute the data. And imputing the data would mean, for example, if you're a transfer student, you may not necessarily have a high school GPA in our database. So if we wanted to use that piece of information, we would have to impute it. So set up a standard value for all of those missing values in order to be able to use the data. Because the problem is whenever you're doing any type of predictive analytics, if there is missing data, you cannot use that observation. So if there's individual pieces of missing data in many observations, you're going to limit the amount of analytical work that you can do because you're going to have less data to use. So it's important in some cases that we are able to impute the data. So the fourth step is data exploration. So we're going to form hypotheses about the defined problem by visually analyzing the data. So this is what's known as our EDA, which is our exploratory data analysis. And you might use a tool such as Tableau here to put together histograms, line graphs, just try to understand the individual variables that you're trying to build into a model. So data exploration is key. Feature engineering is step 5. You're going to select important features and construct more meaningful ones using the raw data that you have. So in regression analysis, what you may use are interaction terms. And interaction terms are basically you're multiplying those two terms together because sometimes you can have significant individual terms, and sometimes because two variables work very strongly together, you try and interact them to see if that variable will work as well. So you can put together you can just use not only the variables that are in the database, but you can create new variables as well. Again, trying to get the best model for the product that you're looking to produce. Step 6, predictive modeling. This is where you're going to train the machine learning model, evaluate the performance, and use them to make predictions. So in the predictive model, we're going to develop the model using our key significant variables. And then we're going to test it to see how effective it is. And in this step also, we will also look at how fit the model is, how good it is. And the last step is our data visualization. So now that we have all this information, we've taken the unstructured data or structured data, and put it together into a model. What we want to do now is be able to present it so for our stakeholders so that they can effectively see what it is that we've actually done here. So this is where you're going to be communicating your findings. You may be using something like Tableau in order to create those data visualizations. So these are the 7 steps of the data lifecycle, and each of them are important, but you need to do these step by step in order to have an effective product at the end. So what are some of the tools that we can use for data science? So there's many tools that we can actually use, many web applications. Some of the most popular notebooks are Jupyter RStudio if you're using R, and Zeppelin. Networks are actually very useful for conducting analysis, but do have their limitations when data science need to work in a team. So who oversees this data science process now? Well, most organizations, data science projects are typically overseen by 3 types of managers. Well, the first is known as the business manager. And these are managers that work with the data science team to develop the problem and develop a strategy. They may be specifically in the line of business. So they understand the business better than anybody else in the team. So they'll help the data scientist produce the best results. Second are the IT managers. Well, the IT managers are responsible for the infrastructure and architecture. Those are the managers that manage the tables, the data tables. And they're obviously critical so that they can help the data scientists identify where the key variables are that they may need to bring into their modeling. And then we've got the data science managers. So these are the managers that actually oversee the data science team and the day-to-day work. But the most important player is the data scientist. That's what you're going to be doing as a data scientist on a day-to-day basis, doing that heavy lifting of all the hard work that we talked about in the data science lifecycle. So in general, what is a data scientist? It's a relatively new field, data science. But a data scientist's duties can include developing strategies for analyzing data, preparing data for analysis, exploring, analyzing, visualizing data, building models, using Python, or you can use SAS as well, and then deploying those models into applications. But what is really important is that a data scientist doesn't work by themselves. They work in a team. So it's really important that you have good communication skills so that if you run into issues, that you can report them to individual managers, or if you have a specific problem with a piece of data, that you can get your answers quickly so that you can continue to work and model effectively.